Perhaps the most frustrating of the significant digit mathematical rules is the addition and subtraction rule. Not because it's difficult, but because it forces us to do a very specific type of addition and subtraction that we have to just get used to. Now, the way that we do this addition and subtraction mathematics to make sure we get the right number of significant digits in our answer is this. The answer must be rounded so that it contains the same number of digits to the right of the decimal point as there are in the measurement, with the smallest number of digits to the right of the decimal point. Now that sounds very confusing. And the fact of the matter is it is. So I'm going to show you a process for us to do this so that we get it right every time. So let's say, for example, we want to add these two measurements. 2.89 meters. And this works with subtraction as well. I'm just going to do addition in this example. In 0.00043 meters. Now, here's the thing. In order for this to work, we have to force ourselves to do our addition vertically. What do I mean? Well, this is what I mean. All of us may have been taught how to do addition and subtraction in many ways. Chances are you've learned the vertical method. The vertical method is that we take our measurements or whatever we're adding and we line them up vertically, making sure the decimal point is what lines us up. We were adding 2.89 meters to 0.00043 meters. So now what I'm going to do is I'm going to move my meters out of the way. Add my horizontal line and my addition sign. There's a reason for us to do this. Now, what all this verbiage is saying in the rule is that when we get our final answer, our answer can only be as accurate as our least accurate measurement. So, what we have to do is we need to find the least significant digit. And the way we do that is we draw an arrow, use a different color here, starting from the right of each measurement until we hit our first significant digit. Okay, hit a 9. We do the same thing for the next measurement. Okay, I hit a 3. Now what we do is we draw a vertical line just to the right of the digit that is farthest to the left between these two digits. The one that's the farthest to the left is the 9. Draw my vertical line. I usually like to do it in dash marks. Okay, we've set ourselves up for success now. Now we just carry out our addition. 3, 4, 0, 9, 8, decimal, and 2 meters. All that's left to do now is we round. And what this vertical line has done is it's showed us where we round to. It's saying the number just to the left is the number where we're rounding. These are going to be our significant digits. So, our 9 look to the right, it's a 0, 9 stays the same. Our final measurement is 2.89 meters. Now, if we stop and think for a second, it kind of makes sense with the knowledge that we have. If we had a measuring device, a ruler, that was accurate enough only to the thousandths place, it could only measure 2.89 meters. And we're adding that to a length that had an accuracy of much better than that. It makes sense that adding that high level of accuracy to something with such a low level of accuracy, that we're only going to end up with this measurement in the first place. It doesn't make sense to someone that doesn't understand significant digits in accuracy and measurement, that adding a quantity to a number, that we would end up with just the same quantity that we started with, right? But it does make sense to the kind of person that understands accuracy and error in measurements. So this is the process you want to follow for addition and subtraction with significant digits.